In this problem, you're going to use a mixture of algebra and calculus to figure out the key features of the graph of the rational function x divided by the quantity x squared plus 1. You will first locate the horizontal asymptote, then find the first derivative in order to determine where the function is increasing and where it's decreasing, and then the second derivative to determine the concavity of the function f. A standard step in graphing rational functions is to locate vertical asymptotes, but in this case the function has no vertical asymptotes. You look for vertical asymptotes where the derivative is 0, but in this case, if x squared plus 1 is 0, then you know that x squared is negative 1, and that just doesn't happen. Often in graphing rational functions, you should check for symmetry. We're not going to ask you to do this, but we're going to run through it really quickly here. This function has odd symmetry, meaning the function's value at minus x is negative the function's value at x. In terms of the graph, you can figure out quite quickly that f of 1 is 1/2, and symmetry tells you then that the function at negative 1 must be negative 1/2. And more generally, whatever the curve does to the right of the origin, it will have to do something similar, but sort of reversed, to the left of the origin. And just so I don't confuse anybody, those curves I just drew, just a wild guess. I don't know yet what the function's going to look like.